Hello and welcome. I'm Savalian, a software dev/creative, and this is the final installment in my critter modeling series. We modeled this creature, this bear, in Blender. We rigged it up for animation, animated it, and now we are going to export our model from Blender and import it into Unity. In this video, I'll show you all the settings I use for export and import, and I'll show you how to add a material in Unity and also set up the Animator Controller. At that point, you'll be able to use the model in Unity just like if you had gotten it off the asset store, and it'll have the extra benefit of being exactly what you want because this one you've made yourself. Now, the very first thing I'm going to do is actually add something because I realized I said I would show you how to add additional objects like hats, and then I forgot to do it. So we're going to do that really quick. I'm just going to add a cube as another object not as part of the bear mesh, and I'm going to model it into a hat really quickly by just rounding it out, extruding some pieces to make a brim for the hat, and then I will use the same material that my bear uses and UV unwrap to give it some color. Now this is where things got a little bit tricky. As you'll see, parenting to bones doesn't actually work when you export, and I didn't know this, but what I do in this video is I select hat first and then the armature, go into pose mode with both of them selected, and then you're able to select individual bones, and I selected the head bone, clicked Ctrl P to parent the hat to the bone. This would work if we weren't exporting it to Unity, and actually I was able to fix it, so it's not a serious problem, but you'll see when I get there that this kind of didn't totally work the way that I wanted it to work. What I would recommend doing, actually, there's actually two options. One is to export it totally on its own, and then manually parent it to the bone in Unity. Another thing you can do, and this is what you'll want to do for modeling things like clothing, anything that needs to sort of bend with the mesh as it's animated, is actually go through the exact same process where you parent the object to the armature itself, not just a single bone, and then weight paint it just like we did for the bear. And actually there's a process I use for copying weights over. It's the data transfer modifier. I won't talk about it in this video because it's kind of involved and you have to have a lot of things set up first. But if you want to just Google data transfer mesh weights, something like that could get you started. But if there's interest, I could also do a video on how I do swappable armor because it's really cool. It's just really involved. So there's not really the scope for that in this video. But don't worry, you're gonna see the hat import in like a weird position. Don't worry, it'll get worked out. Now, with our bear mesh, our hat mesh, and our armature all done and animated, we are ready to export our model with its animations. Now there's actually two different ways that you can export animations. One is exporting them as NLA strips, non-linear animation strips, and using that for export. The other way is just exporting them as actions. In the past, I feel like I've had some problems with exporting actions, so I've occasionally gone the NLA route, but I personally would try the action option first. And if it doesn't work for you, go back and do the NLA stuff because it's just an extra step. But if you do want to add NLA strips and export those, you can open the NLA editor in any panel just by splitting off a new panel, using that little drop down to pick NLA editor. And then in the action editor, which you should still have open, you can push down each action, and there's a button that just says push down. And what this will do is it will convert this action to a strip on the NLA editor. You can then move them around in the sort of timeline here and play, different animations together. Sometimes I like to line them all up end to end so I can just play all the animations in a row and check them out before exporting, but that's not necessary. What's important is that you're able to still get back into your base pose. So don't overwrite the base pose with something else, because you want to make sure your mesh is in that base pose before we continue to the next step. So select it in your action editor, or go scroll over it in the NLA editor, whatever you want to do. Now select the mesh, the rig, and any objects you've included. You can either include the hat, as I mentioned, parented to the rig, or you can export it separately. Once you have your object selected, make sure you don't have any lights or cameras or random objects selected that you don't want to export. And then we're going to go to File and Export to FBX. I know that in recent years Unity has added support for Blender files, but when I've tried to use blend files in the past, it has been very slow, very clunky, and I'm not sure that it works with animations. I've never tried it, and I believe this is the way it's just generally recommended to format your animated 3D models. The export menu has a lot of options, so we're going to go through these one by one, and if I don't mention something, that means that the default value is fine. I'll talk about the things that are important, and I'll just sort of skip over the things that are good at the default settings. The first thing is that we were very careful in our selection because we want to check the selected objects one to make sure we're only exporting the objects that we selected and no extras. Next, down below where it says apply scalings, we want to choose FBX unit scale. So in Unity, they have their own physics engine, their own idea of scale, and one Unity unit is typically, because of the physics engine, considered to be about a meter. Blender has its own scaling system that is different from Unity's. So if you leave this at the default setting, what you'll usually end up with is an object that is 100 times the size when it's in Unity, but by selecting this, it sort of converts that scale to something sort of generic to the FBX file format rather than the Blender units, and so is able to convert those into the Unity units easier than if you leave it as the default. There's also a difference in how Unity and Blender define their 3D space. In Blender, the y-axis runs front to back and the z-axis runs up and down, but in Unity, the z-axis runs front to back and the y-axis runs up and down. So in order to get our model facing the right way, we need to select y as our forward axis, and I accidentally selected -y here. That just makes it face backwards. It's not a huge deal. I'll probably re-export this the right way. You used to have to flip the model around in a special way to get it rotated correctly, but Unity now has an import option that we'll talk about when we get to it, called bake axis conversion, that makes this all work out mathematically. So those are the only options you need to worry about if you're exporting a mesh that is not animated. But since we do have animations, we have a couple more things to look at. And one thing that wasn't immediately clear to me when I started exporting things in Blender is that you can scroll in this export menu. The settings down below are kind of hidden, but you can scroll down to look at them. There's nothing in the geometry section that I typically change, so that should be fine at its default settings. In the armature section, we definitely want to check only deform bones. If you remember our Rigify rig, it has a ton of bones in it, and the vast majority of those bones do not affect the mesh. They're only used for posing the skeleton, managing constraints, changing the angle of certain things, but they don't actually move the mesh, they just move other bones. And because of how Blender works, we can't export those constraints. So when we check only deform bones, this means that only the bones that actually deform the mesh will get exported with our model. It results in a much cleaner, much less dense skeleton that's easier to work with. I also usually uncheck add leaf bones. I'm not sure when you would want to add this one, but basically what it does is add an additional bone that represents the end of each bone. So in Blender, the bones look like sticks, they have a length to them. But when you export them in FBX, they are just points at a single position with a position and a rotation and a scale. So the leaf bones basically act as a way to keep track of the end of sort of the last bone in a chain. And I don't think there's a use for this in Unity. There may be a use for it in other programs, but I've always been able to uncheck this. It makes the armature just a little bit cleaner and it doesn't seem to harm anything. So that's everything in the armature section. The last category here is bake animation. Most of these default options should be fine. The exception is whether you decided to go with the NLA strip export or the action export. If you put all your actions into the NLA editor, you'll want to uncheck all actions here and just keep the NLA strips checked. Otherwise, keep all actions checked. The only thing that happens if you have both of them checked and you made those conversions is that you'll have 2 of every animation clip, which is not a huge deal. You can just remove them in Unity, but it's a little thing that saves you some time later. You can uncheck NLA strips if you're using the action option, but you don't have to, because if you didn't actually put any NLA strips on the editor, they won't be there to export. So with all those settings, we are now ready to hit export. Make sure you know where you're exporting this to. I have a folder that I save all my creature models in. I use this specific naming scheme so I can keep track of which one is which. Hit export and you should find your creature at the path that you picked, ready to go. And now we're going to open up Unity. I'm assuming that you have a Unity project ready to go, or that you've created one to use for this video. But somewhere in your asset hierarchy, you should have a folder for your 3D models. Unity's pretty smart about importing, so all you have to do is open up your File Explorer and just drag the file in, and this will create a copy of it. I like to maintain a sort of source model, and then the Unity asset model is a copy, so that if I ever need to make changes, I can always export it without interfering with what I've got in Unity. And it was at this point when I clicked on the object to look at the import settings that I realized that parenting to a bone in Blender doesn't export properly. So like I mentioned, if you have an accessory that is actually weight painted to the armature, that should import in the correct position, but apparently the offset position is not kept when you export from Blender, so this is actually okay. I typically do accessory objects in a different way, but I can fix this, so I'll show you how to do that. But for now, just ignore it. So if you click on a model file in your assets, you can always see the import settings, and you can always change these and reapply them if you notice that you missed something or you want to import it a different way. And there's a couple of settings we need to tweak in here before we're ready to use this model in a game. So let's start on the first tab, Model, which has a ton of settings. We don't really need to worry about a lot of these, but there are a few important ones. First, remember when I mentioned the axis differences, we need to check Bake Axis Conversion so that our model faces the right way. And if we got the scaling option right in our export, we should also see that the scale is 1, not 100 or 0.001 or anything like that. And I'll also mention now, if you ever need to re-import it, you can delete your model from the asset folder and drag in a model with the same name, and it will update any references that you have in your scenes, but it will not save the import settings. So you can replace the model very easily, but you will have to come back in and adjust these import settings if you do that. Another import option you might be interested in is if you plan on doing any code changes to the mesh, like I do with UV sliding. You'll want to check Read Write Enabled. The only thing that will happen is if you try to access mesh data and you don't have this enabled, it will throw an error, so make sure if you're going to be doing that you have this checked. And then another option that you may be interested in but is a matter of preference is the normals section. So normals are basically the way a face faces. It affects how it's shaded. So if you have normals that face, more farther away from each other, then a corner of the mesh is going to have a harder edge. But if you smooth the normals, there will be a smooth edge there. It won't look like a corner, if that makes sense. So sometimes I like to use the calculate option, which will, instead of using your exported values from Blender on the normals, it will recalculate them. You can use this to sort of automatically smooth out flat faces that are made out of multiple faces. You can change the angle where it will decide that the edge is like hard or smooth. And so you can play with these settings. I sometimes use them and I sometimes don't, depending on how it looks once I've got it in here. And that is all the options in the model tab that I usually change. Let's move on to rigging. This is where you decide how you want to import your rig. If you have a humanoid rig, there are going to be a lot more options here where you can select humanoid. It will try to figure out like where all the different bones match up to the generic humanoid bones. But for non-humanoid meshes, the only option we have is generic. And what we want to do here is select create avatar from this model. This will basically save like a reference to the armature so that we can create our animator when we get to that step. So we'll need this or we won't have an avatar to connect the animator to. And that's all we can do on this page. Next, the animation tab. In here, what you should see is a little box with all of the animations that you made for your creature. You can remove the base pose at this point. You don't only needed that for exporting, so we can just delete it, select it, and hit the minus. You can also rename your animation clips if you want to. I named mine pretty well when I did it, but it does add this little object name, so I'm going through here and deleting those. And as you select each animation, there's a couple of settings you can change below. The most important one for this video is this loop time checkbox. You want to check this for anything that should loop, so the walk animation and the idle animation. If it's not checked here, it won't loop, so when you put it into your animator, they're gonna walk 2 steps and then they're gonna stop. Like I said, you can always come back in here and update these import settings and then just hit apply and it should update. You can also make tweaks to the animations themselves in this little view. For example, if you somehow have a bit, like an extra bit at the end of your animation that you want to cut out, you can change. There's little sliders on the timeline that you can change the start and end time. We designed our animations to be exactly the length that we wanted, so we don't need to do this, but if you've ever gotten animations from a pack, like on the asset store, or you got it from someone else and they've put all the animations into one big clip, this is what you would use to sort of cut those little clips out of the larger clip. And there's also some things like animation events in this import menu, which I'm not going to talk about. That's a little bit advanced. But those are in here if you want to do something with those as well. And that's everything in here, so I'm just going to make sure we apply these import settings. And we're also going to talk about materials for a second. When you first pull in your model, it might have no material, or if you used a texture with the same name as a texture you have in your project, it may be able to pull that in automatically. But often I find that the material itself is just the default material with the texture applied. So what I do is I go into this material tab in the remap section. You can select the material here and that will set it. Or if you pull your object into a scene, you can just drag a material onto the object and it will update the material that way. And then I often will make prefabs for my creatures anyway, so I just make sure that prefab has the correct material assigned to it. Either way, if you want to go into the materials tab, you want to do it sort of manually in your scene, either way should work. I just wanted to point out that when you import this, it doesn't actually have the material information that you had in Blender, so you'll need to make a material in Unity, adjust any settings like metallic roughness or things like that, and then apply it to your object and make sure that you're using your same texture that you used for the UV unwrapping. Now I'm gonna drag my model into a scene, just a plain scene, so I can see it as I'm setting everything up. And in fact, I'm gonna fix the hat real quick. So typically I do export accessory models as a separate object and import them, on their own and add them to the object myself. But basically, if we go into the model in our scene and we sort of dive down into this hierarchy here, we can see that it has pulled all the different bones of the rig into Unity. They're all in this hierarchy of objects, and this hierarchy is the same as the rig in our Blender project. These are just game objects. They're converted to game objects. And as you animate, all these bones will move. So they still get animated just like they would in Blender. And what you can do is you can just parent random game objects to certain bones and they will follow that bone just like if you parented it to a bone in Blender. So I'm going to flip the hat right side around. It's already parented to the head bone, but if it wasn't, I would just drag it in and drop it into this bone object here, and it would be parented just like that. But I can flip it around and position it so that it's on the bear's head instead of floating around in the front. And then when we do animate, you'll see the hat will follow this head bone just like it would have if we had stayed in Blender. Now that we have that fixed, we want to make this bear move, which means we're going to need an Animator Controller. There used to be ways to play individual animation clips. That's kind of deprecated at this point. They really want you to have an Animator Controller for every animated object in your game. And we're going to do a really simple one. These things can get kind of crazy. So we're going to do one with the idle animation, the walk animation, and then 2 simple trigger animations for the attack and for the death. Just to show, the basics for this video. So an animator is actually a separate asset. You can create one in your assets folder by right-clicking and choosing Animator Controller. Double-clicking on that in your asset folder will open up the animator window. I usually like to just dock mine down next to the asset folders. And the way that animators work are that they are state machines. So you have a number of different states, and each of these states has an animation attached to it. And then you can add transitions between those states that are either automatic, when the animation's done, or they're based on a parameter that has changed that you can set from your game code. To start, let's add a state for the idle animation. So we can right click, add state. If I click on it, I can adjust things in the inspector. Motion is the clip, so we can click on this little dot, find our bear idle animation, and this is why I mentioned giving these things detailed names really helps, because I could just type in, Crete05 and it will bring up, the bear animations. And a lot of the settings for each state are really for adjusting the motion so that it lines up cleanly with other animations as it's transitioning. We don't really need that. These are all pretty simple, but all of these settings are here. You can mirror it, you can play it at a different speed or reverse it. You can name the state as well, which I recommend to help you keep track of which one is which. And then this state is also orange because it's the default state. This is going to start playing by default and then transition as necessary to other states. So with our model in the scene, we can click on it and then select this animator as its Animator Controller. And if we start up the game just with this one idle state, we can see the idle animation is playing. So let's go back to the animator and add our walk cycle next. We can right click to add another state, do the same thing, give it a walk name, add our walking clip. And now, once we have these 2 states, we are going to right click on the idle state, choose Make Transition. We'll get this little arrow that follows our mouse. We want to click on the walk animation to transition from idle to walk. And this creates a little arrow. If you don't do anything, it should transition at the end of the initial state into the second state, but we only want it to transition to walk when we're walking. So this is what we use parameters for. And you can have parameters of different types. So in the panel to the left of the node view in our Animator Controller editor, we can select the little parameter tab, click this plus at the top, and then add a parameter. I want this one to be a float. I'm just going to call it move speed. And then in our transition, there's this little section called conditions. In there you can add a condition, and because move speed is our only parameter, when I add one, it's going to select that, but you can click the drop down to pick a different parameter if you want, if you have one. And we want to set it so when move speed is greater than either 0 or 0.01 or something, we want to transition to this walk animation. We also want to uncheck has exit time, because what this does is it forces the animation to play until it's done, basically. So if we leave this on, it's going to play the entire idle animation before it starts walking, and we don't want that. We want it to interrupt it immediately and transition to that walk. So we uncheck exit time on this one. And we're also going to need a transition back from the walk to the idle. So right click on the walk state, make transition, click back on idle. Now we should have two arrows, one going each way. We can click on this second transition, add the move speed condition, and then just swap it around. So instead of greater than 0, we want less than, like 0.01, something really small. And within these transition options, you can change how long the transition takes. You can change where in the animation it happens if you have that exit time. But often for simple animations, I find that the defaults are good enough. Unless it's a very realistic set of animations, you typically can't notice if there's a little tiny bit of a hiccup. And make sure you uncheck has exit time on both of these transitions. And now we're going to add another parameter. This time it's going to be a trigger. What triggers do is basically they are booleans under the hood, so they're either on or off. But the way the trigger works is that when it's turned on, it will transition and then turn itself off, so you don't need to manually set it back to false when it's done playing. So I'm going to do one for my basic attack animation, which I just call basic. I'm going to make a new state, and then for the motion for this state, I'm going to pick my basic attack animation the same way that we did the other two. But for this one, we want to be able to always transition to the basic attack, whether we're in walk, whether we're in idle, whether we're in, whatever state. And so instead of making the transition from idle, I want to use this any state option. And this means that no matter what the animator's doing, if this happens, if this condition happens, it's going to move into this state. So we can make that transition. We can make sure that the condition uses that trigger so that it only happens when the basic attack trigger is activated. And then unless we have an animation here that is meant to be final, like a death animation, we do want to transition back out of this state. But just like before, we don't want to go back to a walk state or an idle state because we don't know where we belong. So I'm just going to use exit. And what this will do is it will sort of restart the animator, so it'll go naturally back into idle, but then if we are moving, it will transition into the walk from there. So we're just going to do a normal transition, and we want it to just transition back when it's done. So we want to leave the exit time checkbox on for this one. And so what that's going to do is it's going to wait until the basic attack is finished playing, and then it's going to exit out and then sort of reset itself back to the beginning, which is what we want. And actually, as a demonstration of what it looks like to go into a state permanently, let's add the death animation too. And to do that, just the same thing, we do add a new state, select our animation clip, give it a name, and then for this one I'm going to do the transition from any state again. We're going to create a new trigger for final, I've been calling it, for the death, and then add that trigger to the transition. But instead, for this death one, we're not going to have it exit. It's just going to be a dead end. We're going to go into this and there's going to be no way out. Except you'll see if we do trigger the basic attack, it will sort of re-enter the cycle. So that's a little trick. But a cool feature of the Animator Controller is that we can adjust these parameter values while the game is running. So you don't actually need to hook up any code to see your animations in action and all their transitions. We play the game, we'll see we start in idle. If I change the move speed to something higher than 0, we'll start walking. Back to 0, we'll stop walking. And then I can just click on the triggers and it will set them true. They'll play through their transition and then it will set itself to not true. So you can just go back and forth and watch how these interact with each other. This is a good way to see if you've forgotten to make anything loop or if you've got the timing wrong on anything. But you can pretty much just play around in here as long as you want and see everything the way it would look in your final game. So there we are. From here you would instantiate this creature either by putting them into a scene or by in code instantiating them and placing them in the scene. And then what you can do is you can get a reference to the Animator Controller, either by using get component or creating a variable and dragging the Animator Controller into that variable. And then you can literally just do like the animator variable dot and then set bool, set trigger, set float, and just set the values for your parameters here. And that's it. We have our creature built in Blender, exported, pulled into Unity. It's fully animated, the animator's hooked up, the material's on it, and he's got a little hat. Perfect. You can use this model, you can make another one. For whatever kind of game you're making, you can sort of design your own creatures, get the animations just how you want them. You now have the skills to create your own fully animated character meshes for a Unity game. You could basically do whatever you want, so go wild. And that's gonna be it for this video and for this little series. Let me know if there are other Unity or Blender skills that you're hoping to see videos on. I really want to put a focus on making videos that are going to be useful and help people and that people are actually going to use. So I would love to hear what you'd like to see. And if you don't have any requests, just let me know in the comments what kind of creature models you want to make. Thank you so much for watching. I had a lot of fun with this little series. Don't forget to like and subscribe because I will be back soon with another video, and I hope to see you there. Thank you, and goodbye.